Hi friends, in this session we will going to do the data analysis of CRD design. We consider here two replications and 19 treatments. So it's easy to do the data analysis in Excel. You can use the different sources which is available on the website and also many apps available in the market like SPSS, then R script and OPStat also available online. You can do that analysis on that software as well, but it's easy to do the analysis in Excel because it's a real-time analysis, and if we need to modify anything in this, then we definitely do the modification in Excel. It's easy and it's a real time. Okay, so in this design, this is for the equal number of replications. We simply called it replications or observations or plots. So you can see here in this first table, you need to provide the character name. For example, I take character as a plant weight in grams. Okay, you can consider the plant weight in gram. So below you can see here the number of treatments. We consider the total number of treatments are 19 with respective the replications or observations or plot. In this design, we consider two replications. It means you consider as a two plots or two observation per treatment. So here you can type your observation manually like this, or just you need to the copy of data from different sheets. Okay, just copy the data, come back to our design, just select first cell, right click, and you need to paste as a values. Okay, all values are came here. So you can see here what you will get in this design. We will going to discuss. So you can see here the treatment total. You will get the treatment total, and here you can see you will get the grand total that we called GT. So here also we will get the treatment average. Also you can call it mean. Okay. So below that you will get the replication total and replication average, but we don't consider replication total and replication average in CRD design. So below that very important table we will going to see, that is ANOVA table. Let me enlarge it. Okay, let's see here the source of variation. We consider the single source of variation in the CRD design. We don't consider the replication variation as a source. So you can see here the treatments as a source of variation. Below that you will get the residual, or it's called as error. So and below you will get total. And you can see the next column, you will get the degrees of freedom. I already given here the formulas for how to calculate the degrees of freedom for the treatment, error and the total. You can see here the formulas T minus 1, T minus T and N minus 1. You can calculate on the basis of this. If we consider our treatments are 19, then 19 minus 1 is 18. Likewise, you can calculate for the errors and totals. After that, we need to calculate the sum of square. It's a calculation part. We can summing the total of all the treatments. You can see here the formula. We need to square the each treatment total and we need to sum it and divided by the number of replications, and we need to subtract correction factor. So we will get the sum of square. Now you can calculate the sum of square for error and total sum of square. And here is the important mean sum of square. It's easy and simple. Mean sum of square divided by degrees of freedom is equal to mean sum of square. Then you calculate for the error or residual. Then F calculated is here and F table value for 5%. And after that you will get the very important column, that is significance. Whether our treatments are significant or non-significant, we can consider that over here. If you can see here the NS, it means it is non-significant. Non-significant, it means all treatment having same effect. So there is no difference among the treatments. So here is non-significant. If here is SIG, it means significance. Then we can call it all treatments are significant. It means there is a difference between the treatments. So if you will get the significance, then you need to calculate CD value and post hoc analysis. Okay. If your treatments are non-significant, then don't do the calculation for CD and post hoc analysis. Okay. So you will get the significance for 5% as well as 1%. Below that you will get the CV value. You can see here the 33. It's a too high value. Okay. So if you conduct the experiment in lab or in polyhouse or in control environment condition, then we should have to consider CV value less than 5%. Okay. If your field experiment or open field experiment, then we consider greater than 5 or less than 20%. Keep in mind these values are very important. Now you can see our treatments are non-significant. So you can see here our CD value for 5%, 177.40. So you can put these values. If your treatments are non-significant, then you can just put here NA. Okay. Now below that we will get the graphical data representation. So before that we can see the final thesis table. On that basis we will make the graphical data representation of that table. So you can see here you will get the final thesis table. In this final thesis table you will get the number of treatments. You can able to write the treatment name and you will get the treatment average. It means treatment mean. You can take here the values for standard error plus minus, then CD value for 5%. If you want to put the 1%, then definitely you can add this 1%. You can take it from this table. Okay. Below that you can see here, this is fully automatic design, so that you can see here the graphical data representation of our final thesis table. So you need to give the name for this table. For example, which character we analyzing in this session, that is plant weight in gram. So that you can give here the title plant weight. Below that you see here the axis title. Axis title you should have to mention here the treatments, and here you can mention the plant weight in grams. Okay. This is fully dynamic design, so that you need to only copy paste this red color values only, or you can just give the input one by one, or just copy from your tables from different sheets. Okay. If you want this type of Excel sheet, then you will get my WhatsApp number in the description box. Then definitely you go to the description box and just contact me. I'll give you quotation for this Excel sheet. If you want, then definitely you can use this. If you want to modify data, then this is the very important sheet. Otherwise, if you use the different softwares like SPSS, then R script, or then OPStat for the online, then it's very difficult to do the modification in your data. But in Excel you will get the real-time result. If any query regarding your research, then definitely contact me or just comment below. Then definitely I'll answer all your queries. Thank you so much for joining.